This is video 511, and the goal of this video is to know what it means to verify an identity. So first, what is verifying an identity? An identity, first of all, is when two expressions are equal, and in our case it's all these trigonometric expressions with sine, cosine, and tangent, and so on. And we're trying to show that two expressions are equal because that's what verifying means. Verifying means to show two expressions are equal. We're going to show that these two things are equal all of the time for any angle. The key here is that we're trying to show things are equal. So we're not going to assume they're equal, we're trying to prove that they're equal. So we're never going to assume that this is an equation. So they give us an identity that's an equation, and they say verify it, which means prove that those two sides are always equal. Now this section over here are all of your different identities that you will not have to have memorized, but you want to become very familiar with because they lend themselves to all of these verifying identities. We're going to use them to simplify, we're going to use them to solve equations. So the better you are with these, the more likely you are to succeed in this chapter. So now let's take a look at our first hint. The first hint for all identities that you're verifying is to start with the more complicated side. So we're not going to start with the side with cosecant of x. We're going to start with the side with secant of x cotangent of x. Now I am going to keep in mind what the other side is and what it has on it, but I'm not going to do much on that right-hand side. I'm just going to be familiar with it. I know that the right-hand side is cosecant of x, and cosecant of x is 1 over sine of x. So I'm familiar with that enough to know that I'm looking for 1 over sine of x. Now what I'm going to do on the left is slowly start to change things around. And I'm going to change things around by replacing these values with things that they're equal to. So secant of theta is equal to 1 over cosine of theta, so secant of x, 1 over cosine of x. Doing the same with cotangent of x, I'm going to replace it with cosine of x over sine of x because they're equivalent values. I'm going to multiply these two fractions, but before I do, I'm actually going to simplify them because the cosines cancel out when we have 1 on top, and on bottom they divide to make a 1, therefore canceling out. In the end, I'm simply left with 1 over sine of x, but wait a second, that's exactly what cosecant of x is equal to according to the reciprocal identity. So now I'm writing my final equivalence that 1 over sine of x is cosecant of x, and I'm actually done verifying this identity. You're finished verifying an identity when you have turned one side into another side using equivalence statements. So notice I did nothing with the cosecant of x, I simply worked with the left and turned it into the right. Let's take a look at the next example. So the next example, again, we're going to start with the more complicated side. But my hint here is that you should try and change things to sines and cosines. They tend to be the equalizer, the guy that's in the middle that everyone can turn into fairly easily. So if we change things to sines and cosines, we're a little bit able to see where to go from there. So I'm going to take everything on the left and I'm going to change it to sines and cosines. So sine of x is going to copy. Tangent of x, I'm going to use the tangent identity of sine over cosine and change that to sine of x over cosine of x. And cosine of x, again, I'm just going to copy. Now, interestingly enough, I'm going to do it on the right-hand side as well. And that is because that's where I'm headed. I can meet somewhere in the middle, and that's another hint that we'll write down in a little bit. I can keep in mind that I'm looking for 1 over cosine of x. Since I changed everything on the left to sines and cosines, I should do that on the right as well to see where I'm headed. So now I'm going to work on this left-hand side and try and turn it into 1 over cosine of x, because then I will make that full circle back to secant of x. So let's take a look at how I'm going to do this. Cosine of x is the denominator here, and when I times cosine of x times sine over cosine times sine of x, I'm going to get sine squared of x over cosine of x. And I'm going to add it to cosine of x. Now cosine of x is over 1, and I want it to be one single fraction. So I'm keeping in mind where I'm headed. This is a lot to explain in these first examples. I'm having a tough time finding my words, but I'm keeping in mind that this is where I'm headed. And so I want to have a single fraction, and right now I have two fractions here, 1, 2, or two quantities, I want to put them together. In order to do that, I need to know about fractions, and I need to get common denominators. So I'm going to get a common denominator of cosine of x, because of course that's my denominator. And to do that, I times cosine of x, the right-hand side, by cosine over cosine, because that's just a clever form of 1. Now I'm going to rewrite this now as cosine squared of x over cosine of x, because fractions you just multiply across the top and across the bottom. The left-hand side I'm just simply going to copy down. So notice that we're almost near our goal. We got a cosine of x in the denominator, just like our goal is. We have these cosine of x in the denominator, but again, we want to put them as a single fraction, so I'm literally going to add them together now and put sine squared of x plus cosine squared of x all over cosine of x. Now I'm very close to my goal here. I want to get 1 over cosine of x, but in order to do that, the top needs to be 1. But the good news is, it is 1. So don't ever forget where you're headed. I'm thinking about where I'm headed. I want the top to be 1, because that's where I'm headed. The bottom is good. I've got the bottom of the fraction as cosine of x, but I want the top to be 1. And the identity I use here is the Pythagorean identity, because sine squared plus cosine squared is 1. So I'm left with 1 over cosine of x, which is equivalent to secant of x. So I've done a full circle, turned the left-hand side into the right-hand side. Let's take a look at example number 3 and your 4th hint for the video. So the final hint here is to factor. You will often need to factor in order to simplify. So be prepared to factor and work with some factoring tricks that we'll talk a lot about in class. So what I see on the left-hand side is that I can factor out a cosine, because cosine times something is cosine x minus cosine x sine squared of x. Cosine x is a common factor. So I'm going to factor that out. And cosine of x times 1 is cosine of x. Cosine of x times sine squared of x is cosine x sine squared of x. So I undistributed is the same thing as factoring. So these two values are identical based on the fact that we've undistributed. We've used a distributive property. Now keep in mind where I'm headed. I'm headed with cosine to the third, which means 3 cosines being multiplied together. I take a look at where I'm at. I see I already have 1 cosine. So somehow this second piece has to equal cosine of x times cosine of x. So let's take a look at how I can introduce some more cosines into the mix and kind of get rid of what I don't want. See the 1 there? We already have an identity to replace the 1 over here with sine squared, cosine squared. So sine squared of x plus cosine squared of x can be replaced by the 1. And then we still have that minus sine squared of x. Now we'll simplify what's in the parentheses there, canceling out the sine squareds. We're left with cosine squared. Hooray, we're left with what we want. We're left with cosine of x times cosine squared of x, which of course equals cosine to the third x. And we have met our goal of turning the left-hand side into the right-hand side. So you kind of have to be clever. You have to take some options and take some different routes. And you'll only get better with practice. So it's very important you keep up with your assignments this chapter. Here's your multiple choice question and your free response question. So do your best to simplify the expression on the right. Your goal is to notice that your goal is to turn it into a single value from here to here. So see what you can replace. My hint is change things to sines and cosines, and you will need to use the Pythagorean identity. So see if you can figure out how to turn that complicated expression into one of the 4 multiple choice options. In the free response question, your goal is to rewrite the expression in terms of sine and cosine and simplify. So rewrite it in sines and cosine, simplify it up, work with your fraction skills, and then tell me what your simplified result is in terms of sines and cosines. So good luck, bring your questions into class, and we'll see you tomorrow.